After first part of the illumination, now we are going to the next part, that is the design part. Here there is the problem. In this problem, a drawing hall of engineering college is to be illuminated with illumination of 144 meter lumen per meter squared, and the room size is 30 meter, length, breadth is 20 meter, and height is 8 meter, and the mounting height of the light is 5 meter. Here utilization coefficient is given 0.6, maintenance factor is given 0.75, and space height ratio is maintained 1. Here two types of lamp is given. One is 300 watt lamp, another one is 500 watt lamp. So, how can this room will be illuminated by the required illumination? In that type of problem is processed by certain number of steps. First step is you should calculate the height. Here space by height ratio is 1, so the space is 5 because the mounting height is 5. So written space by height is equal to 1, space divided by 5 is equal to 1, that is the space is 5 meter. This is the first step. Second step is calculation of flux. The flux is calculated with the help of the formula EA by eta P. E value is 144, A value is 600, eta value is 0.6, and P value is 0.75. So by calculation the flux is 192,000 lumen. Now how much amount of bulb is required? One bulb is 300 watt lamp. So 1 watt is equal to 13 lumen given. So 300 watt is 13 into 300, that is the 3900 lumen. So number of lamp required is equal to total flux divided by flux per lamp is given by 192,000 divided by 3900, that is the 49. So if you use 30 watt lamp, we have required 49 number of lamps. Next one is second type of lamp is 1 watt given 16 lumen. So 500 watt given 16 into 500, that is the 8,000 lumen. So number of lamp required is total flux by flux per lamp, that is 192,000 divided by 8,000, that is the 24. Now number 4 is rough calculation. Here space is maintained 5 meter. That means between the two lamps space is given 5 meter. So across the length, to maintain the space, number of lamp required is 30 meter is length, space requirement is 5 meter, that is the 30 divided by 5, that is the 6 number of lamp across the length. Now come to the breadth. Breadth is 20 meter, space is 5 meter, that is the distance between two lamp is 5 meter. So 20 divided by 5 is equal to 4. So if you multiply 6 into 4, that is the 24. So 25 number of lamp required. So we have required 500 watt lamp. So here put this length is 30 meter, this breadth is 20 meter, and making the difference between the two lamp is 5 meter. So this is a 5, 5, 5, 5, 5. So it is 10, 15, 20, 25. But the length is 30 meter. 30 minus 25 is 5 meter is remaining. 5 meter is distributed from the wall. This is the 2.5, 2.5. Why 2.5? 5 divided by 2 is 2.5. Now come to the similarly in the length. This is the 5 meter, 5 meter, 5 meter. So 5, 10, 15 meter. 15 minus 20, that is the 5. 5 divided by 2, that is a 2.5. So this distance from the wall is 2.5 meter. So this picture is the layout of the room. If we taken the 49 number of lamps, it was unsuitable to install certain high number of lamp into the specified space. That's why we cannot take 49 number of lamps, or each lamp rating 300 watt. Okay, so we are illuminated the space with only 500 watt lamp. The requirement of number of lamp is 24. Okay, thank you.